complex fractions today. All right, so this is going to be apparently 6-4. Complex fractions. Oh.
Oh my gosh, I'm so good.
They look more intimidating than they are.
You sure about that?
Oh my god, I watched Wonder last night. And it was so sad. It's such a good movie. I watched it.
Wait, what's Wonder?
It's a movie about the communication.
Oh, I love that
I
movie.
know. It was so good.
Yeah. Yeah.
So first of all, I just want to explain what a complex fraction is. Oh, the stupid glare.
The glare has come a long way since the beginning of.
That's true. That's true. I think the black curtain has helped.
Yeah.
But anyway, so a complex fraction, very simply, is just a fraction that has a fraction in it. So either your numerator or denominator is also a fraction. So it's a fraction with fraction in it. That's all we mean by a complex fraction. So your steps are really kind of easy. It's just a matter of knowing how to do those steps. Okay, so how to simplify I'm going to abbreviate it as a CF because I'm lazy. Complex fraction. Step one. And sometimes you're going to get lucky and step one will already be done for you. We don't know. So first thing you're always going to do is you are going to combine the numerator or denominator of the main fraction to get only one fraction on top and one on bottom. So basically, if you start off with a problem that has two fractions being added together, either in the numerator or the denominator or both, you want to do that addition or subtraction. So I want to eventually get it to be one fraction over another fraction. I don't want to have a fraction plus a fraction over a fraction plus a fraction. I don't want that. I need a single fraction over another single fraction. Because then once I get there, now life is kind of easy because it's really just a division problem. And how do we handle division of fractions? Keep, change, flip. So once I get it to a single fraction over a single fraction, I can rewrite it as keep, change, flip, multiplying by the reciprocal. Okay, so it's just step one that can be kind of tedious. But then step two, once you have this, rewrite as multiplication of the reciprocal. In other words, keep, change, flip. Come off. And then I guess once you have it rewritten as a multiplication problem, then you just simplify like we've been doing all last week. because now it's just a normal multiplication problem. We're gonna factor everybody, cancel. So I'll just add that, just to refresh your memory. Now simplify by factor everyone, then cancel. And that's it. Those are your steps. It's just going to depend on the problem, how easy or difficult this process is. So let's start off with one that's super easy. Like I'm looking at number 2 on your worksheet. So on your original worksheet, we have x squared over 4. And then I always like to draw with a bigger fraction bar when I'm writing it, just so I can clearly see the main fraction and then these like little sub fractions, right? It's a lot easier. I think even on the worksheet, are they all the same way? Yeah, like it gets confused. Like it's always the one in the middle is the big one, right? Yes. So if you just kind of elongate the middle one, I think that will visually help you. So this one, luckily, number 1 is already done for me. I already have a single fraction divided by a single fraction. So this one is literally ready for step 2. I'm just going to rewrite it as keep, change, flip. So you keep the first fraction, your numerator, that does not change. So that's going to get rewritten as, I keep that first fraction exactly as I see it, x squared over 4. I change the big fraction bar becomes multiplication. And then I want to take the reciprocal. I want to flip the bottom one. So that becomes 4 over 1. And now this is a multiplication problem. Factor everybody. There's no one to factor. And now I can cancel. Yep. You can't do that. When you have the only time that you can square root something is if you have an equation and you're going to square root both sides. You can't just take a number and square root it because now you've changed its value, right? If you have $16 in your pocket, I can't just come over and square root it, right? You'd be pretty ticked off. What I could do is I could exchange you, say you had a 10, a 5, and a 1. I could exchange you for 16 ones. And you still have the same value. You get what I'm saying? Yeah. So you haven't changed its value, but you can't just go around square rooting expressions. Okay. Yeah. Okay. So I'm here. I did step 2, and step 3 says now simplify. Factor everyone, then cancel. Well, no one needs factoring, right? So who cancels? The 4s cancel, right? Anything on top would cancel with anything on the bottom. So my final answer in this one is literally just x squared. All done. Well, that one was easy. Okay, let's try another easy one. How about 4? You guys try 4. Then we'll try some tougher ones. Hey, you got an answer?
Yeah.
Well, this one is a quick one. Step 1 again is already done here. I already have one single fraction over another single fraction. So we'll rewrite it, keep, change, flip. Keep the numerator just like you see it. Change to multiplication, and then I want the reciprocal of the denominator. So that becomes 3 over a. So when you rewrote it as multiplication, did everybody have this 2 over a squared times 3 over a? Okay, and now the third step is just to simplify. So factor everybody, nobody needs factoring. And then I'm just gonna cancel. Does anything cancel? No, this time it doesn't, right? So don't get thrown off if nothing cancels. Sometimes nothing cancels, right? That can totally happen. So I'm just gonna multiply straight across. My final answer, I get 6 over a to the third. Did you? Okay, let's do one that's a little bit more involved, though, where you do have to do a step 1. I'm looking at number 7. Okay, so number 7, the original looks like this. We have 1/2, and we're gonna divide 1/2 by 2 over x plus 4 over x. So this time I'm not starting off with a single fraction divided by a single fraction. So I do have to combine these two in my denominator, right? To turn them into a single fraction. Lucky for me, right? If you just ignore the numerator for 1 second, just pretend that that's not there. This is a problem like we did last week, right? I have to add these two fractions together. What do you need to add two fractions together? Common denominators. We lucked out because they have common denominators already. Yes. So will they always? No, of course not. But in this problem, they do. So let's enjoy it while it lasts. So let's just go ahead and, so I'm still on step number 1. I'm just going to add these two together. So what's my new denominator going to be? Say it again.
6 over.
Oh,
6, excuse me, yeah, 6 over x, right? I just add the numerators, so of that down there, right? So 2 plus 4, I get 6 over x. Now I'm ready for step 2, cube change flip. So go ahead and try it if you haven't already. Cancel anybody if anything cancels. And what's our final answer? X over 12. Okay, let's step it up a notch. I actually don't want to do 8 just yet. 8 is a little bit tougher. Let me start off with number 10 looks okay. Let's look at 10. We'll keep increasing our difficulty.
so scared.
Don't be. As long as you there's only 3 steps. You got to remember that. And really, once you get past the first step, then it's like easy street. I hate when there's A's and 9's in the same problem. It's my 9's and A's look too similar, I think.
Yeah, but, oh, wait a minute.
Oh. Okay, so here is our original, number 10, right? Okay, so I don't have a single fraction over another single fraction. Too bad, so sad. But at least I only have to combine the numerators, right? Sometimes I have to do both. Sometimes I have to combine the numerators and the denominators. Oh, we'll do that in a minute. But this time I don't have to. All right, so let's start off with that numerator. So literally, I just want you to focus on one. I'm just going to cover that one up. Remind me when you guys take your test. I'll give you a Post-it note so you can do this if you want. All right, so I'm pretending the denominator doesn't even exist. I just want to add those two fractions together. How will I do that? I got to multiply them by each other, right? These two denominators, the only way to get them to match is to multiply this first one by 3 over 3 and the second one by a over a. So can we agree that now both of them have a denominator of 3a? All right, so when I add those numerators together, so that's going to be 27 plus a. So I'm just gonna get a new fraction, 27 plus a all over 3a. Do we all agree? Okay, now remember, the denominator of my original problem really does exist, but luckily that is already a single fraction. So now I can keep my numerator as it is. Let's change it to multiplication, and then we'll just do the reciprocal of this. And now I'm looking for anything that can cancel. I actually don't think we have anything. Right, because it's part of a binomial. In fact, I'm gonna flip this around because I like that variable to be first. I'm gonna rewrite it as a plus 27. But yeah, I don't think anything is gonna cancel. So when I write my answer, do you have to FOIL it all together? No, you don't have to. So I'm just gonna leave it as a plus 27 over a minus 5 over, now in the denominator, that's just 27a, right? That's my answer. That's the best I can do. So what?
It's annoying, because there's like so many things that you could do, but you can't.
I do like a satisfying problem where a lot of things cancel, but you know, sometimes it just doesn't happen. And that's okay. That's right. You get what you get and you don't get upset. Okay, let's try one of these harder ones that has multiple fractions. Oh, which one looks the hardest on the whole paper?
17. I was just saying something.
17?
Yeah, that's super.
Oh, wait,
So
well,
it's Maddie.
no, I think
18.
18.
I was just gonna say, I think 17 is easier than
17 has a lot of numbers, so it's like a lot.
Yeah,
But I
18
feel like
would
18.
All right, let's do 18 together.
So-
And I think I'm gonna flip my page just so I have more space. I'm running low. All right, so let me just write the original, give myself lots of space here. Okay, so here's the original. There we go. All right, so my original problem, I have fractions on top and fractions on the bottom. Too bad, so sad. So, but you know what the good news is? You only ever have to deal with one set at a time. So let's just see you later, denominator. I'll deal with you later. I've got a lot on my plate here. Okay, so I need to get common denominators. You can factor an x out of this, but then I'd have x times x plus 2. I'm still gonna have to multiply them by each other. Do you see that? Sometimes, like if I could factor a 2 out of this one, then I can be like, oh, cool, this one's just missing that other piece. But they don't have any pieces that are the same. I mean, I know you see a 2 in each of these, but I can't factor a 2 out. You get what I'm talking about?
Yeah.
So I'm gonna have to multiply them by each other in this case. So let's do it. So the first one's gonna get multiplied by 2 over 2. And the second one's gonna get multiplied by x squared plus 2x over x squared plus 2x. Can we all agree that these two fractions do now have common denominators? Okay, so my first one, when I multiply 2 times 2, I'm just gonna get a 4. Right? Now, be careful, this is subtraction. So I'm gonna have to multiply through this x, but then I gotta subtract everybody. So what you could do is you could just distribute a negative x, and that would take care of it. So if I do negative x times x squared, that's gonna be a negative x to the third. And then if I do negative x times 2x, isn't that going to be a negative 2x squared? So when I multiply that through in my numerator, so let's combine all of this. I'm going to have a negative x cubed minus 2x squared plus 4. And it's all over my common denominator, 2 times x squared plus 2x. Does that make sense or have I lost you? Right, so what you could do, right, you could just distribute the x, then you'd have x cubed plus 2x squared. But you got to minus all of that. So instead of it just being x cubed, it's now got to be minus x cubed.
Wait, what happens to the, isn't there a 4?
Yeah.
Oh,
Right there.
oh,
I just put it in standard form when I rewrote it.
oh, okay.
All right, so everybody's okay now?
What's 2x squared?
Because you had x times 2x.
Oh my gosh, yeah, sorry.
And then I gotta subtract it. Okay. So now I'm here. So I've gotten the numerator to be one single fraction, right? Right? Okay. Now, it's not a nice one, but that's okay. It still is a fraction. Now I gotta look to my denominator. So that's gonna be my numerator, right? It's there. Let's see what secrets lie underneath the Post-it for the denominator. Woo! Oh, how nice. Such a simpler fraction to deal with. So I'm going to ignore the numerator for a moment. And I'm just looking at this denominator. Oh, okay, this is doable. How am I going to get these the same? Yes, I'll have to multiply this one by x over x, this one by 8 over 8. So when I do that, I'm going to get x plus 8 over 8x. Agreed? Okay, now step 1 is done. But now the rest of it isn't really not that bad because now it's really just a multiplication problem and you guys are aces at the multiplication. So now I do keep change flip. I'm going to keep the first fraction as I see it. Negative x to the third minus 2x squared plus 4 all over. And you know what else I'm going to do? This does factor a little bit more. Like, couldn't I factor an x out of that?
Yeah.
So I'm going to rewrite that as 2x if I pull out the x also, and then it's just going to be with x plus 2. So now that is completely factored. So there's my numerator. I'm going to change the multiplication and I'm going to flip this one over. 8x on top, x plus 8 on the bottom. Oh, sorry, I didn't realize I wasn't on the screen. Now it's a multiplication problem like you did last week. It's not,
The numerator on the first one is like weird.
but it doesn't even factor, so I don't even have to touch it.
Oh, it's not that. Wait, but.
Well, step 1, when you have a multiplication, you factor everybody. So I don't even, this top doesn't even factor. There's nothing I can do with that. Well, it's not quadratic.
So it's not quadratic.
I mean, if it had 4 terms, I'd try and split it in half and factor both sides. But I don't have 4 terms. There's nothing I can pull out of the whole thing.
And you do it if it's x squared. Not even x, like you can't do it quadratic.
So everybody is already factored. So now step 2 is just cancel. Does anybody cancel? Yes, 2x and 8x, I can cancel those two with each other, right? Right, the x's are just going to cancel completely. So that x and that x are just gone. And then 8 over 2 just becomes 4. So I'll have a 4 right there. Anything else I can do? Can I do what? These two? You want to cancel those two? The 4 and the 2? You can't. Yeah, that's part of a binomial.
No,
The-
that's not what it's.
Oh, I'm sorry.
The for the last term.
The 4 and the 8.
The 4 over on that side.
This 4 that I'm pointing to right here.
No, the 1 over.
Oh. That one?
Yeah.
Cancel it with who?
the 8 on the side.
Oh, you can't still because he's a binomial. Yep. So I'd have to have an entire x plus 8 up on top. Can't touch him.
It's done.
It's done. Well, I mean, yeah. So we should write it nice though.
Yeah.
So up top, if you want to distribute that 4 in, you can. You don't really have to though. So I would just write it like this, minus 2x squared plus 4. And then my denominator, I just have that x plus 2x plus 8. And that's it. If it's multiple choice and you don't see your answer exactly like that, maybe they distributed the 4 through the top. Mathematically, the exact same thing. If it's, you know, if that was a test question that wasn't multiple choice, you could give it your answer any which way, as long as all of your pieces are there. Let me have you try one that maybe isn't quite so bad before I tell you what I want you to do. How about 14? 14 is a very reasonable one. So you try that all by yourself without me guiding you through. See if you can get to your very final answer.
Wait, hold on. I meant this stuff right now.
I'm not, they just like threw three times.
The numerators a plus 3 and then a plus 2. Like, would it be a plus 13?
No, I.
Oh, okay. So you can add those together. What's it minus?
Hey, what you gonna say?
Wait.
I don't know, mess me up.
Yeah, where's your- Stop. Yeah. I thought I knew what I was doing.
I only disagree with the top part.
Oh, really?
Yeah.
You just, I think you, oh, wait, same. See, I pushed up 5.
Well, you can't take that and put it back to plus. Oh, you have to add this, so it'd be a plus 13.
Oh.
Then your 5, you have to.
Wait, you said
What?
so it's
Did you say something about your mama?
I said, I'm.
Oh.
So you can add it.
Okay, so this is.
No, the bottom's right.
I really
Yeah,
love.
the top.
Oh, how about this? I think this step to just, could you get there? Maybe. Oh, okay. This is. So you can't simplify it. Oh, so I lost that. No, so because.
Whoa.
Okay, everybody, you got an answer?
Yeah.
Yeah?
I think it's great.
Yeah.
All right, we're gonna find out together. So step one, we're going to, I'm gonna ignore the denominator just for a moment. See you later. Okay? Oh, I have a subtraction problem. I must get common denominators. I'll do that by,
Multiplying A.
yes, the first fraction only needs to be multiplied by A over A. Now they match. The second one's already all set. It's already A squared. So when I combine those two fractions, that's going to get me 5A minus 5 all over A squared. Everybody agree for the top fraction? Yeah, all right, now we're gonna forget about the numerator. Oh, I just messed up my, there we go. Let's pretend that the numerator doesn't exist now. Let's only look at the denominator. Oh, okay. Two more fractions to combine. Is everybody with me? And these, I can get them to be, what am I gonna do with these? How do I get common denominators here?
2.
Yes, I gotta multiply the second fraction just by 2 over 2. And now at least they both have a denominator of 4. So now when I do that, 5 times 2 is 10. So when I'm adding these numerators together, I have A plus 3 plus 10. Isn't that just A plus 13? Yes, so I'm gonna get A plus 13 over, my common denominator is just 4. Oh gosh. There, step one is now done. I have combined the numerators, I have combined the denominators. Now I have one fraction over one fraction. Now I do keep, change, flip. Right? So I'm going to keep the first fraction. I'm going to move down here. Keep the first fraction as it is, 5A minus 5 over A squared times, flip this one over now, 4 on top, A plus 13 on the bottom. And now it's a multiplication problem. I can factor this one. I can take out a 5, A minus 1, but I don't think it's going to help me at all. Do you guys see anybody that cancels? No, too bad, so sad, but sometimes there will be, right? In this case, there just isn't. So then I just multiply it all together. So my numerator, I'll have 20 times A minus 1. If you distribute that out, that's fine. You don't have to, but you can. And then in my denominator, I'm going to have A squared times A plus 13. And that is as far as I can go besides just multiplying that in, which is optional. So you can do that or you can just leave it. Okay, does this seem reasonable? Now that you've tried some?
It's okay.
Yes, it's doable. Okay, so I think what I would like you guys to do is just the odds. I think we did
Oh, come on.
Wow.
we did number 7.
We did the even.
I did all the evens.
Exactly.
Guys, the whole ones on the front are already ready. It's already keep, change, flip time already for the whole front.
Hey, can we just do the front page?
Oh my gosh. this-
No.
Yeah, can we just do the whole front
No,
page instead of
guys,
odds?
no. You have like 6 problems to do. I think that's,
Wait, we're doing
Hard.
evens?
no,
Wait, we're doing evens?
you're doing the evens. We have
The
already
evens?
done number,
Really?
oh no, the odds.
No, you just said the evens. I'm so
No,
confused.
the odds, the odds, the odds. You
You're
tricked me,
confusing
tricked
me.
Only on the front though, right?
No, both, all odds, front and back.
Only even?
Don't try and trick me. Odds, both sides, totally doable. Remember, we don't slow down until after we pass the finish line. And that finish line is June 15th.
Oh my god.
Yep.
Yeah.
Wait, so for here, we're actually like.
Give me 1 second, I'll come to you. Just tuck this way.
I don't know if this is tomorrow. No, I'm like being so serious with that. I
Tomorrow,
want.
yeah.
Okay, yeah. Or I can just check it.
Ooh, that's
It's
great. I
not
think you
bad.
should shut the lights back
Yeah.
off.
The key?
Wait,
Yeah.
Oh,
lights
you mean
back
like,
off?
no, you guys gotta
Like,
see.
if you like post an answer key so I can like, or like put it on the board or something so I can just see like the person.